You may remember Hess's law as this form here, that the standard enthalpy change of a reaction is the standard enthalpy of formation of the products minus the standard enthalpy of formation of reactants. Let's consider that. We have a reaction. Finally, we're going to talk about some chemical reactions instead of gases all the time. So here we have reactants, and they go to products. And this has a certain enthalpy, standard enthalpy change here. Now what you do is you go through a thermodynamic cycle like we talked about a few sub-lectures back. You take the reactants and put them into their standard state. Like O2 would be the standard state, O2 gas would be the standard state for oxygen. Standard state, remember, is at 25 degrees. And then you take them from the standard state and go to the products. So we'll call this delta F, delta H of formation. Actually, let me be more specific. If we go the other way, we go this way, this is the standard enthalpy of formation of the reactants. Okay, so we're going from the standard state, the elements in the standard state, and we're going to form the products. And that, from introductory chemistry, is called the standard enthalpy of formation, reactants, standard enthalpy of formation of reactants. Now we're going to take the elements in the standard state, we're going to rearrange those, make products. So this would be the standard enthalpy of formation of the products. Now this is a thermodynamic cycle, so going from here to here is the same as going from here to here and then going from there to there. The enthalpy change will be the same because enthalpy is a state function. So delta H0, the standard enthalpy of that reaction, will be equal to the, now note that this is going that way, so in order to go through this thermodynamic cycle, we're going to have to take the negative of this. Remember, when you reverse the sign of or reverse the direction of reaction, you reverse the sign of delta H. So this will be minus delta H, the standard enthalpy formation of the reactants, plus, going from there to there, is the standard enthalpy of formation of the products. Reactants, products. This is Hess's law. So there it is, Hess's law. It just comes from the fact that enthalpy is a state function. Well, not only enthalpy is a state function, also energy is a state function. In fact, you can do this thermodynamic cycle for any state function. So there it is, there it is, there it is. So all these things just follow for the fact that enthalpy and energy are state functions. So maybe a little deeper understanding of Hess's law.